So I'm going to start here. That's my opposite. What else can I label on this triangle? Hypotenuse should be 17. It's across from the 90-degree angle, which leaves 8 to be our adjacent. Again, this little mnemonic, SOHCAHTOA, could help you remember the trig ratios very quickly. So we could write out the fractions now. Who can tell me what's the sine of u going to be? 15 over 17. And we're always going to ask ourselves, can we simplify that fraction? Does something go into 15 and 17? No. Okay. Then we're going to write the cosine of u. 8 over 17. Can I simplify that fraction? Does something go into 8 and 17? No. Finally, the tangent of u. 15 over 8. Can I simplify that? No. You could write it as a mixed number. Have you heard that before? Yeah. 1 and how many eighths?
7 eighths.
Sure. I'm not going to get that extra on the test. Okay? But that's an equivalent form that you've heard about in middle school math. Right? I know, we love fractions. All right. This was just to get us ready for lesson 8.4. Today we're looking at 8.4. And we've been talking about the ratios or the fractions of the sides. Now we're going to throw in the angle part. And we all will need a calculator today. So let's go to our lesson where it says unlocking the triangle. That's where we're starting today. And I'm going to help us with this lesson because there's a lot going on. There's a lot to remember. It says, what information do we need to solve a triangle? Can we find the key to unlocking any right triangle? So if we look at this first triangle, WUV, I know two sides. What equation helps me find a third side if I know two? Pythag, right? So what other information could we use? We could use Pythag theorem, right? We could use Pythag theorem. Number one says, given that triangle UVW, what's that squiggle mean? From last semester. What does that mean? Not congruent. Similar. It means similar. If you forgot that, I would label this as similar. So it's saying if triangle UVW is similar to triangle ABC, then find the hypotenuse of the second triangle. Man, what do you remember about similar figures? What are the two criteria for similar figures? Turn and talk to your partner. Be ready for me to call on you. Turn and talk to your partner. Proportional sides. Proportional sides, not congruent sides, just proportional. Oh no, we're using another mathematical word to describe this. What does proportional mean? Not congruent, not the same. Does someone use similar? Man, we keep coming back to these math terms. What does this mean? Proportional. I'll have a scale factor. One's smaller, one's multiplied. Proportional. Okay, that's one criteria. What's the other criteria for similar triangles? Proportional sides, same shape, meaning same angles, right? Congruent angles. Okay. How does having a similar triangle help you determine the missing sides? Well, we know we're going to have a scale factor involved here. A scale factor. I know this hypotenuse. I know this side, and it corresponds to this side. maybe I could set up an equation. What if I set up this equation? I'm going to use the sine. So the sine of W would be what over what? Great. And the sine of C would be 10 over X. That looks familiar. What could I do to solve for that side then? Cross multiply, and that's what it's asking us to do in part 3. It says find the sine of W. We did. The sine of W is 6 over 18. Find the sine of C. We did. It's 10 over X. And now let's cross multiply and solve for X. 6 times X equals 18 times 10. You're dividing both sides by 6, and we should get X, or our hypotenuse, is 30. Great. We use similar triangles. We used our sine ratios to help us set this up. Great. Number 4. Let's look at a new triangle. A completely new triangle. If the sine is 2/5, can you find the missing lengths? I want you to turn and talk with your partner. How does 2/5 help me find the missing lengths on this triangle? Turn and talk with your partner. Give it a try now. All right. So now it's asking us, is theta, this angle right here, again, this is theta, this is an angle. Is it the same measure as angle W in our very first triangle? Why or why not? Let's compare. I can see that the sine of theta in this triangle right here would be 14 over 35. We just solved for X. We just solved for X. And the sine, opposite hypotenuse, for this triangle right here is 14 over 35. Does that fraction simplify? What does it simplify to be? 2/5. 2/5. You could also grab your calculator and do 14 divided by 35. What's the decimal? If you're not sure about simplifying fractions, what's the decimal? Try that. What's the decimal? 0.4. And we're trying to compare it to our triangle above, and that triangle was the sine of W equaled what? What was the fraction there? 6 over 18, which simplifies to 1/3. What's 1/3 as a decimal? Use your calculator in front of you. 0.3. Repeating. Are these angles congruent then? W and theta. What do you think? They're not congruent because their ratios of the sides don't simplify to be the same fraction. We've got ratios of sides are different, so we do not have the same angle. Let's summarize that. We've got ratios not equal. Therefore, the angles are not equal. How does knowing the sine ratio help you determine the missing sides of the triangle? Well, again, we can find your hypotenuse, right, for sine. We can find the opposite. And if I wanted to find the third side, what could I do? Back to the very beginning. If I know two sides, what could I do to find the third side? Pythag, right? So we've got some different strategies now. If I know triangles are similar, I could set up and cross multiply. I could use a scale factor. Or I could use a squared plus b squared equals c squared. Unfortunately, the triangle in number 4 is not similar to the triangles above. So these patterns don't hold true. Do you follow me so far? We're looking at similar relationships. Similar triangles should have the same sine, cosine, and tangent ratios. The same angles. We following? Okay, number 6. Number 6. Can you figure out the missing side lengths of this triangle? What do you guys think? We have a side and an angle. Is that enough information? No. Do we know a similar triangle? So I could set up a cross multiplication problem? No. So I don't have a similar triangle. I don't have enough information right now. Leave some space, please. What we're going to look at today is we're going to use the angle now. See how we have an angle? We have 40 degrees. Bless you. Instead of theta. Now we're going to use the calculator to help us out. Let's identify our sides. This would be our opposite. This would be our hypotenuse. And 5 would be our adjacent. I'm going to start with cosine. And I'm going to label my hypotenuse x. So let's write a ratio. The cosine of 40 degrees equals what over what? SOHCAHTOA. $40 degrees is my angle, so let's use our sides. What do we know? What's it going to be? 5 over x. Okay? All right. Grab your calculators. Here's the calculator part. No. Here. All right. This is telling us this ratio. So now I know the cosine of 40 is just a number. It's 0.766 and so on. I'm not going to write it yet. I just want to solve for x and watch what's happening here. So I'm going to put the cosine of 40 over 1 so that I can cross multiply. Are we okay with that? We know the cosine of 40 is just a number. We saw that on the calculator. So now I'm going to cross multiply. So x times the cosine of 40 equals 5. How would I get x by itself? X times the cosine of 40. The cosine of 40 is just a number. How would I get x by itself if I'm solving algebraically? It's x times. What's the opposite of multiplication? We're going to divide. Let's divide both sides by the cosine of 40. Again, it's just a number. So now, x equals 5 divided by the cosine of 40. Why did Miss Rose do this? Because I don't want to do this calculator part till the very end so I know what I'm typing in. So now in my calculator, I'm going to type in 5 divided by the cosine of 40 to get my exact answer. And we'll do that together on this calculator. So now we're going to do 5 divided by the cosine of 40 to get our side length. So I'm going to clear that. It's a lot of work. It's just different. We're solving. That's my side length. So this side length is about 6.52. So if I know an angle and if I know a side, I can find the other side. So check it out. If I know, right, we found this is cosine, this was adjacent, this was hypotenuse, that I just found this is about 6.52. How could I find the other side now? I know two sides. Pythag. Right? So now we're putting it all together. Last thing, how could I find this other angle? We're putting a lot of things together. Yes.
Oh my gosh, I completely forgot.
Okay, it's okay. We know this is 40. We know this is 90, 180, minus whatever those add up to be. It's 50. Do you see how we can find all the missing pieces on the triangle now? Wow. Wow. Flip your page for the quick notes. Here we go. Okay. Let's summarize what we're doing. Here we go. Today, this is what we saw. We can use the calculator to find the sine, cosine, tangent of any specific angle measure. Two more things we did today. I don't think we actually did it, but we talked about if I know two sides, I can use Pythagorean theorem. To find a missing side. If we know two. And the last thing we did in problem 6 that I just modeled for you is we can solve for an unknown side using a trig ratio. We're going to practice this in the check for understanding. Number 1 is looking at similar triangles. Number 2 is where we're actually going to solve like we did in number 6. And then in number 3, we're putting it all together. We're solving for all the unknown sides, all the unknown angles. So I'm going to help us get started with number 1. I don't want us to get hung up too long on number 1. 1, it says, if the cosine of theta is 4/5, find two possible sets of measurements for all three sides. The cosine. So again, SOHCAHTOA. So the first thing you should do is start by labeling. This is my opposite. Hypotenuse adjacent. Where should I put 4 and where should I put 5? Say that again. 4 where? 4 is my adjacent. 5 is my hypotenuse. How could I solve for that third side? Pythag. Okay, which one's A and B and which one's C? Uh-oh. Hypotenuse is always C. 4 squared plus unknown squared, and we could solve quickly. 4 squared, 16, 5 squared, 25. We're going to subtract 16 from both sides. X squared is 9. So then what's our final answer? What do I do to get rid of an x squared? We square root. So that means this side is really 3. Yay. Without doing a whole bunch of work, if these are similar triangles, how could I find another possible set? Someone pick a scale factor. What do you want to do? 2? Sure. Let's scale it up by 2. So if I scale this up by 2, meaning times everything by 2, what's my new adjacent side going to be? 8. What's my new opposite side going to be? 6. And finally, my new hypotenuse side. 10. Could I find another possible set? Yes, by doing what? Picking a different what? Different scale factor. Are we good with that? What's the relationship between these two triangles? They're similar, right? They're similar. They're going to have the same angles, proportional sides. Yes.